Welcome to the Unit 4, Day 7 notes. Go ahead, pause the video, and solve this system of linear equations. You can use whatever method you want. When you're done, unpause it and see how you did. So you can use any method. I'm going to choose to use the elimination method. That gives me 2x plus 8y equals 20 on top. That didn't change, but the bottom is now 4x minus 8y equals 20. So I can add these things up. I wrote 4x. I was getting way ahead of myself. That should be a 2x right there. And a 4x comes down here. Plus 0y equals 40. So 4x equals 40. That means that x equals 10. I'm going to plug that into the original equation there. 10 minus 4y is equal to 10. Subtract 10 from both sides. You've got that y is equal to 0. So my answer is going to be positive 10, comma 0. If you graphed it, they're going to intersect way over there. You can see that that's probably not the best choice using graphing, because that line is going to mostly be off the graph there, which makes it kind of hard to see where they actually intersect. But graphing to get the intersection would give you this exact same value as would substitution. If I was going to use substitution, I would have solved for this x first, because it's an individual x. It would give us the least amount of work. So today, we are basically just doing twice of what we've already been doing so far this year. We're going to be going through word problems and identifying two variables. We're going to be writing two equations, and then we're going to be solving a system of equations. There's a pattern that kind of emerges as we go through, and I'll kind of highlight that more and more as we go. So we're starting off with Mr. Tukulke has been saving the coins that he finds on the ground. If he has 135 quarters and nickels combined and $10.15 total, how many of each coin does he have? The actual sentence with the question tells us what my variables need to be. So how many, so that means a number of, and then each coin. My coins are quarters and nickels. You can use whatever variables you want to. I'm going to use Q for the number of quarters and N for the number of nickels. Like I said, you can use whatever variables you want to. I chose Q and N so that when I'm done going through all of the algebra work that I need to go through, when I see Q equals something, it's very easy to remember, oh yeah, Q stood for quarters. If you pick X and Y, you got to make sure that you go back to what you identified up here. Okay, IDing the variable, something we struggled with last chapter, and I had people saying something and then not using that identification, so you got to make sure you're being very consistent. All right, so I need to come up with my system of equations. The first one is the number of quarters plus the number of nickels is the total number of coins that I have. That one's the easier one. All right, and then my other one, I'm going to take the value of a quarter times how many quarters I have, plus the value of a nickel times how many nickels I have. That's my total cost. So the value of a quarter is 25 cents, so 0.25 times Q, plus the value of a nickel is 0.50, or 5 cents, times N, gives me $10.15. You've got to know the value of the coins. Last year I was always surprised with how many people put 0.5 for the value of a nickel. 0.05 for a nickel, 0.01 for a penny, 0.10 for a dime. All right. Now you've got choices. You use whatever method you want to solve. Graphing, hopefully you can see, is not going to be a great choice because A, we've got some funky numbers, and B, I don't give you a graph. I'm going to choose the elimination method. I'm going to multiply this bottom one by -4. Okay, I chose -4 specifically to get rid of Q, because 4 times 0.25 is 1, so negative times 0.25 is going to be a negative Q minus 0.20N equals negative 40.60. So now I can add these things up. Q's are gone. I have 0.80N equals 94.40. Divide both sides by 0.80. I get that N is equal to 118. Okay, if I've got N equals 118, I can plug it into either equation but please plug it into that one. That one is a million times easier than this other one. So I've got Q plus 118 is equal to 135. Subtract 118 from both sides. We've got Q is 17. Anytime you have a word problem, your answer should be a full sentence. So Mr. T has 17 quarters and 118 nickels. Your sentence doesn't need to be exactly the same as everybody else's. I need to have that information. You tell me nickels first, quarter second, I don't really care. You just got to make sure that your number has the appropriate label. This kind of goes back to why I named the variables Q and N. I don't want to accidentally say I have 17 nickels and then 118 quarters, because that's wrong. It's completely wrong. And you're going to lose points because of it. Even though you just had the label switch and did all your math right, you're going to lose points. So make sure you have your label with the appropriate number. This next question is 100% fantasy, because if you guys have noticed so far, I'm not going to tell you how many questions are on a test, but just for the sake of this example problem, I'm going to tell you that there's 71 points in the next test that has 20 problems. Each problem is worth 3 or 4 points. Because you're studying a system of linear equations, I'm going to tell you that you get extra credit if you can figure out how many problems of each value are on the test. So how many are there? This is 100% fake fantasy. I'm not actually going to do that, but I think it's kind of a fun problem. So the question is how many of each question. Each question is talking about the 3-point and the 4-point questions. So I'm going to use T to represent the number of 3-point questions. And I'll use F for the number of 4-point questions. I didn't highlight this in the last question. I mentioned it, but I didn't really highlight it. Number of is important because our variable has to represent a number. If you say T represents 3-point questions, what you're saying is T represents a question, doesn't represent a value. We know variables need to represent a value. On the quarter and nickels one, we couldn't say Q equals quarters because it equals how many quarters, not just the actual physical quarter itself. All right, so number of these types of questions. If I add them together, that's how many total questions there are. I'm going to take the value of that thing times the number of that thing. So the value of a 3-point question is 3 points times there's T of those 3-point questions, plus 4, that's the value of a 4-point question, times F, that's how many 4-point questions there are. And there's a total of 71 points. All right, that's the pattern that's happening. Is pretty much add the two variables together and set it equal to something, and then take what each variable is representing, like the number of that thing times its value, times its worth. Okay. Now, any method you want to, I'm going to choose the elimination and multiply the top by -3. I chose that. You could have eliminated F if you wanted to. I usually try to eliminate the smallest numbers I can so I don't get big numbers. But when I add these up, it's going to be really nice because it right away tells me, well, it should have been a -20, tells me that I'm going to have F is equal to, shouldn't have been a -20 at all, actually. If I multiply it correctly, -3 times 20 is -60. It tells me F is 11. So if F is 11, T plus 11 equals 20. T equals 9. So there are 9 3-point questions and 11 4-point questions. Make sure your handwriting is good enough for me to be able to read this. I want to make sure there's a clear space between 9 and 3-point, and then I put a hyphen with my 3-point and my 4-point to emphasize that that 3 has nothing to do with the amount of questions. That's just its title, basically. Next one, we're going to Tutti Frutti. We're going to buy yogurt and toppings. The total weight of the yogurt and toppings is 12 ounces. The toppings cost 75 cents per ounce, and yogurt costs 50 cents per ounce. If I paid $6.75 for everything, how many ounces of yogurt and how many ounces of toppings did I get? How many ounces of yogurt is a variable? and then how many ounces of toppings is a variable. I'm going to use y to represent the number of ounces of yogurt. And then, because I'm not very creative, I'm going to use z for the number of ounces of toppings. Now, I did something that's not entirely necessary, but it's going to be a good habit. I said we always need the number of. Technically, in this case, we don't need number of because ounces is always going to be a number. So I'm saying number of a number of ounces, basically. But it's a good habit to just get into having a number of, because we always want our variable to represent a number. So if I put these number of ounces together, I know that I have 12 total ounces from right there. Now I'm saying I'm going to take the value of each type of variable. So the value of yogurt, so the cost of the yogurt, is 50 cents per ounce. Plus the cost of the toppings is 75 cents per ounce. For both of those, I just take the cost times how many ounces I get, and altogether that's $6.75. So I can use whatever method I want to. I'm going to use elimination and multiply this bottom one by -2. So I've got y plus z equals 12 on top still. On the bottom now I have negative y minus 1.50z equals negative 13.5. So when I add, I end up with negative 0.50z equals negative 1.50. Divide everything by 0.5 and also make it negative. That gives me that z is equal to 3. You could also multiply both sides by -2. It's the same thing. Now plug it into the easy equation. You could plug it into that green one, but please don't. So I've got y plus 3 equals 12. So y is equal to 9. So I need a sentence. So Mr. T got 9 ounces of yogurt and 3 ounces of toppings. Now, this is one where some people are going to get the label wrong just because they're not paying super close attention. Or they'll make a mistake getting this part set up. Because if we read carefully, I said the toppings cost first and then the yogurt cost. But then the first question and the first thing we identified was yogurt, number of ounces of yogurt, and then number of ounces of topping. So some people are going to get those things flipped around because the order that they're presented and the order that questions are asked are different. So make sure you're reading very carefully. All right. This next problem is the one that I think is the hardest in the notes, but it still follows that same pattern. So the question itself is how many ounces of each solution. All right. So how many ounces each solution? There are two types of solution. There is a 15% alcohol solution and a 40% alcohol solution. That 25% alcohol solution is what I'm ending up with. So I need two variables. I'm going to use x and y, and I'm counting the number of ounces for both of these. So for x, I'm going to say the number of ounces of this 15% alcohol solution. The reason why I think this one is kind of challenging is because we're using numbers when we're identifying our variables, but only kind of. So ideally, we would not use any numbers here whatsoever, but our variables are both representing an alcohol solution, the number of ounces of an alcohol solution. And I need to differentiate between those two somehow. The only way I know how to do that is to say what type they are. Okay, this is no different than saying the number of ounces of like red paint and blue paint. It just happens to be the only differentiating factor. It's not color, it's the percentage. So if I add those number of ounces together, I know I'm ending up with 30 ounces. That one's the easy one. This next one is the one that's going to throw some of us for a loop. For all of these, we've been taking the value or the cost of each type of variable and multiplying it by the number of ounces or the number of objects, the number of whatever, right? So I'm going to take 15% times the number of ounces of the 15% alcohol solution. 15% is 0.15 times I have X number of ounces of that, plus same thing with y. I had 0.40 times y. And then this right side is the one that is most commonly missed. I'm ending up with a 25% alcohol solution, and what I'm doing for both of these is the percentage times the number of ounces. I know the percentage is 25%, and I know the ounces ends up being 30. Okay, so I multiply that. Now I actually could calculate that out, and that gives you 7.5. So now I've got options. I don't really want to use the elimination method this time because I feel like I have been a lot more recently, and these numbers don't really seem very nice to try to do that with. So what I'm going to do is I'm going to take this top equation, I'm going to subtract y from both sides to get x equals y minus 30. You could do the same thing, solve for y first. I just decided to solve for x first because, well, I felt like it. Don't really have a good reason. But I'm going to plug that in to the bottom equation, because remember, anytime we substitute, we have to plug it into the other equation. And then I'm going to distribute. That gives me negative 0.15y plus 4.5 plus 0.40y is equal to 7.5. Combine my like terms. That gives me 0.25y plus 4.5 is equal to 7.5. So 0.25y equals 3. If I'm dividing by 0.25, that is the exact same thing as multiplying by 4. So y equals 12. I'm going to plug that into this top equation. Subtract 12 from both sides to get x equals 18. So my sentence should be something like the chemist needs 18 ounces of the 15% alcohol solution. If you notice, I took a pause there. All I was doing was looking back. I have notes off to the side here. I was looking back at what I labeled my variable as. So I wanted to make sure I had the correct label. So X was the number of ounces of 15% alcohol solution. And then I'm going to need 12 ounces of the 40% alcohol solution. All right, so then we've got a spot here for you to write a summary of what we talked about today and to write down any questions you may have. Make sure you're working on that day 7 homework. I hope everybody has a great day.